Welcome back, everybody. Let's tackle example 4. Okay, so example 4, again, I have a right triangle that has an altitude drawn through it. I know this is an altitude because when it hits the hypotenuse, it makes a right angle. Okay, and we're going to use our formulas to help us find the missing pieces. Okay, so first what I'm going to do is I'm going to label all the parts of my picture. Guys, which we already know, this is the altitude. So this is the altitude. Okay, X is located on the leg of my right triangle because it's on the 90-degree angle. So X is going to be a leg. I'm going to call it leg 2. It doesn't really matter. It could be leg 2 or leg 1. Really, it doesn't matter. Okay? Now, this is my hypotenuse because it's the side directly across from my 90-degree angle right here. Okay, so this whole thing is the hypotenuse, so we know this 16 is the hypotenuse. Okay, and then Z and 12 are the pieces of my hypotenuse, which Z is closest to leg 2, so I'm going to call it POH2. So this is going to be POH2. Okay, and then the 12 is going to be the other piece of my hypotenuse, so I'm going to call this one POH1. Okay, I can squeeze in POH1. Couldn't squeeze in POH2. Okay, and then depending on either if we're given or if we're solving for an altitude or a leg, that will depend on which formula I use. Okay, so looking here, me personally, I like to deal with the altitude first. I don't know why. I'm just like I have a bias toward the altitude, and I don't know why. But you know, y is sitting on the altitude. Okay, so I'm going to ignore X right now. We're going to act like X is not there, so I'm going to put my nifty piece of paper over it. Okay, so when we are given or trying to solve for an altitude, that is when we use this formula. So if we have something sitting on the altitude, whether it's a variable or a number, that is when we use this formula. Okay, so I'm going to be using the POH1 over altitude equals altitude over POH2. So one piece of the hypotenuse over the altitude equals the altitude over the other piece of the hypotenuse. So I'm going to use that one first. And since y is sitting on the altitude, that means I'm going to find y first. Okay, so I'm going to solve for y first. Also, as we're solving for y, we're going to find z. So we're also finding z. Okay, so let me set up my formula that we're using. Okay, the formula that we're using is POH1 over the altitude equals the altitude over POH2. And remember, since we're doing a geometric mean across my diagonal, I should have a value that's the same. Okay, let's set this thing up, you guys. Let's do it. Okay, so my first piece of the hypotenuse is 12, so I'm going to put 12 over my altitude, which I don't know what it is yet. That's what I'm trying to solve for. That's going to be my y. And then my altitude again is the y over POH2, which I could put z here, but the problem with me putting z here is I'm going to have more than one variable in my problem, which means I'm not going to be able to find y or z if I do that. Okay, but there is a way I can find what z is before I set this up. So let's talk about that real quickly. Okay, if you guys see here, I know the entire length of my hypotenuse is 16. Okay, the entire hypotenuse is 16. This part is 12, so 12 plus what will give me 16. How can I find z if I know part of the hypotenuse is 12 and the whole hypotenuse is 16? Okay, well, if I simply just do 16 minus 12, that will give me what's left over, which will be the remaining part of my hypotenuse, which is z. Okay, so z, real quickly, I'm going to find z over here. Z is going to equal the hypotenuse, which is 16, minus one piece of the hypotenuse, which is 12. So z is going to be 16 minus 12, which is 4. So z equals 4. Yay! Okay, so now I know my second piece of the hypotenuse is 4. And guess what, you guys? From here, you just solve. So let's do it. Let's go. Okay, so I'm going to do this way first. Y times y is y squared. And that will equal the other way. So 12 times 4 is 48. All right, and how do we undo a square? We do square root that thing on both sides. So I'm going to square root it. Okay, which the square root will cancel out the square. Bam. Okay, so we're left with y equals the square root of 48. And don't forget, you guys, what will appear when you square root both sides of an equation? Plus or minus technically appears, but we know in our final answer the altitude length can't be negative, so we won't include the negative. Okay, and then finally, is 48 a perfect square? No, it is not. So how do we solve a perfect square? Or how do we solve when a number is not a perfect square underneath the radical? We do our factor tree, which I'm going to squeeze in my factor tree over here. Sorry, guys. Okay, so let's break it on down. Okay, 48, well, we know 12 and 4 go into 48, so 12 and 4. Okay, 12 will break down into 4 and 3, and 4 will break down into 2 and 2. And this 4 will break down into 2 and 2. Okay, so that's a 2 and a 2. I know I wrote it like really small, so sorry guys. Okay, so do you guys see any cute little couples at the ends of my branches that get to go on their math date? I see 2 couples. I got 1 pair of 2s and I have another pair of 2s. Whoa! And remember, you guys, for each pair, only one number will come outside of my square root. So I have 1, 2 represents this couple, and then the other 2 will represent this couple. And don't forget, each time you have more than one number, you multiply. And then what's my lonely single number that doesn't get to go on their math date? The 3. Lonely 3 stays in for the night. Guys, so my final answer for y would be y equals 4 root 3. Nice. Okay, so we have y done. Okay, so now I'm going to stop ignoring x. So again, you guys, when I solve for x, now I'm going to ignore the altitude. So act like y isn't there as we're solving for x. Okay, so x is a leg of my big right triangle. It is on the right angle. Okay, so when you are given a leg, or you're trying to find the leg, that's when you use this formula, which, remember, it all deals with which leg is closest to which hypotenuse. They are the same formulas, just leg 1 goes with POH1, the part of the hypotenuse closest to it, and leg 2 goes with POH2, which is the hypotenuse part or piece that is closest to that leg. So the leg always goes with the piece of the hypotenuse that is closest to it. Leg 1 goes with POH1. Leg 2 goes with POH2. Okay, so the leg always goes with which piece of the hypotenuse is closest to it. Okay? All right, let's do this thing. Okay, so I already know the formula I'm going to use, so I'm going to set it up. So we have the hypotenuse over the leg, which in this case I labeled it leg 2. You could have labeled it leg 1, doesn't matter. Will equal the same leg, so leg 2, over the part of the hypotenuse that's closest to the leg. Now, which part of my hypotenuse is closest to the leg 2? Is it the 4 or the 12? Which one is closest to this value? It would be the 4. Okay, so this is closest to POH2. Okay, let's set it up and solve. So my entire hypotenuse is 16, so it'd be 16 over my leg 2, which I don't know, so I'm going to call it x, equals leg 2, which is x, over the part of the hypotenuse closest to that leg, which is POH2, which is 4. And then from here we cross multiply. Yay! Okay, so x times x is going to give me an x squared, and that will equal 16 times 4, which is 64. Okay, let's solve. How do we undo a square? We do square root that thing, and I'm going to square root it on both sides. The square root will cancel out the squared. Okay, we're left with x equals, now remember when we square root both sides of an equation, what appears? A plus or minus. But we know a negative leg doesn't make sense, so my final answer, I'm not going to include it. Okay, and is the square root of 64 a perfect square? It is a perfect square. What times what gives you 64? It would be 8. So x is going to be only the positive 8. And that's all there is, folks, for example 4.